Good morning, YouTube. Okay. All right, here we go. Exercise C7X5 says, write a method for the purse class. It's public Boolean, same contents, purse other. What is that? Go away. That checks whether the other purse has the same coins in the same order. Use the following class in your solution. Well, we're going to use our class that we have so far. Okay. So what are we adding? There it is. Public Boolean, same contents, object other. Okay? So we're going to compare two purses. And if they have the exact same coins in the exact same order, we're going to say that's true. We're going to return true for same contents. Okay? All right, so how are you going to do that? Well, let's go to our tester. There's the tester. And we got to add stuff to the tester. All right. Now notice what we have at this point. Gucci has all these coins in it, doesn't it? Right? And Louis is empty. So if I say Gucci dot same contents of Louis would be false, wouldn't it? Right? Look what the method is. Let's see, where is it? Where is my PDF stuff? My PDF went away. That's not it. Where did my PDF go? I thought I had it. All right, went away. All right. What they want you to do, like we have Gucci.transfer Louis, they want you to do Gucci.sameContents of, or what have you. Is that what they call it? Same contents of? Where is it? I put it over here. What do they call it? Same contents, right. So they want something that returns true or false depending on whether the two purses have the exact same contents in the exact same order. Same coins, same order, okay? So if I do Gucci.sameContents Louis, that should return true if they have the same coins in the same order. Right now they don't, right? Last time we checked, Gucci had a whole ton of coins and Louis was empty. So if I do, if I write down if Gucci.sameContents Louis, then I should say they're not. Okay, this is how you test it. Here we go. Let's make a little room down here. Move that up. Let's go over here. Okay, so how about this? If Gucci dot same contents, because it's a Boolean method, I got to put it like in an if statement or something, right? So if Gucci dot same contents compared to Louis is true, then say so. System dot out dot println quote Gucci and Louis are the same.
Wait, what's the name of it?
The method?
Yeah.
It's public Boolean, same contents, object other. Okay. Else, what would you print?
Object what?
It's the signature line that we were given was public Boolean, same contents, object other. Okay, we got to use that signature line, okay? So if this is true, I'm going to say they're the same. What goes here?
Why are we using purse instead?
Why we use, well, because we want to get used to the idea of using purse as an object. I'm morphing it. We're going to talk about that. Remember the equals method that we inherit from the supercosmic object class is like that. It's public Boolean equals object other. We're building up to an equals method, okay? So what goes there? What do you think? What's missing? Else, right, exactly. Else what? Else what? Else they're not. They're not what? They're not the same, so say so, that's all. So I'm going to copy this, put it here, but say Gucci and Louis are not the same. How about that? All right, so that's a test for at least false, because I know that Gucci and Louis at this point in my test are not the same because Louis is empty and Gucci's not. So this should return false, so it should print not the same. But then we have to figure out how to test it for true. We're probably going to have to make a couple of new purses that are the same and see if we can get true to work, just to make sure. Okay? So this is all I added to the tester. Everyone got that? Everyone okay with that? All right, let's go to the other file. Let's see, Purse.java. And we're going to add, now, what is this? Is this a constructor, a mutator, or an accessor? This public Boolean sameContents object other. What is it? It's just an accessor. It's not changing anything. It's just looking at the contents of two different purses without changing the contents of two different purses, right? Good. So here's a constructor. Here's a mutator. Here's a mutator, right? And here's a mutator. Here's an accessor. All right, so how about I put it with the accessors? Let's put it down here. All right, ding, 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 ding. All right, so they gave it to you. Public, Boolean, they gave you the signature line. Boolean, sameContents, camel case, object, other. Now notice how this is different than the method we wrote yesterday. We didn't have object other, we had purse other. So as soon as we get into the guts of this method, we know that other is a purse object, right? We don't know that here. When we get into the guts of this method, other is not a purse, it's an object. Remember, every class that you construct is a subclass of the supercosmic object class. It's almost like you had on this line, public class purse extends object, right? Remember that stuff when we did the grid world class, when we had like public class, what was it, box bug extends bug, because box bug was a bug, was an actor, was an object, right? Remember the hierarchy of the bug class. But this is optional. Java does this for you. You don't have to do this. Every class that you create from scratch automatically does this, okay? So we're inheriting the toString method, and we're inheriting the .equals method. And remember, we had to override the toString method from the object class to work properly with our private instance fields or naughty bits, right? We're going to do the same thing with the .equals method in a moment, but this is warm-up, right? This is warm-up for that, because that's sort of how the equals method in the object class looks. It goes public Boolean equals object other. So we're going to practice this polymorphism stuff. We're going to input from the tester, we're going to input a purse, right? Isn't Louis a purse? We're inputting a purse, right? So the implicit parameter is a purse and the explicit parameter is a purse. But when you get here, we're not calling it a purse, we're calling it an object. But we know it's a purse, don't we? So we can cast it, we can morph it back to a purse, okay? So that's probably the first thing you want to do.
Oh, do purse in parentheses, right?
Okay, let's see. Let's make like a temporary purse object, all right? So let me call it temp, okay? What type is it? I need a local variable, so I have to declare it. What type is it going to be? Purse, right. So I'm going to make a purse object, call it temp, or call it other purse or something. It's not other because that's already an object, right? I need something like other purse or temp or whatever. Equals, well, what? How do you take other and turn it, and morph it from an object to a purse?
Oh, you just do purse in front of it.
Right. So open parentheses, purse. Right? Haven't we done that with double, right? If we're dividing two ints and we want it to really be a double divided by an int or something, we cast one of them to a double. We put a double in there, right? I'm doing the same thing here. Other. All right, since I know from the tester that I'm passing a purse parameter, even though it says it's an object here, I know I can morph it back to a purse, because in some contexts, it's better to use it as an object, more generic. In some contexts, it'll be better to use it as a purse, more specific. And that's what I need to do here. Okay, so now how do you compare the two purses? What are we comparing? What do we want to know? What does this method do? It compares what? It compares two purse objects, right? This purse, which is Gucci, the implicit parameter, and now the temp purse, which is Louis, right? It doesn't have to be Gucci and Louis all the time. We can change that in the tester, but that's what we have. All right, what do we want to know about the two different purses? What do we want to know about them? Well, how did they define equal? It's not technically equal, but all right, how did they define equal? They have the exact same coins in the exact same order, all right? Now, that's really not an equals method. An equals method would be, in my opinion, an equals method would be two purses that have the same value, the same amount of money, no matter what the coins are, no matter what order they're in, right? This is sort of like a weak equals. These two purses have the same contents or sort of equal if they have the exact same coins in the exact same order, right? All right, that's sort of a weak equals. We're building up to a more stronger equal comparison test. Right. So we're going to get to that. All right, so how are you going to go? Don't you have to look at the contents of the array list of each object? The array list being all the coins in each object? Right? Don't you want to take a look at the first coin in Gucci and see if it's the same as the first coin in Louis? And if it isn't, what if it isn't right then? What if the first coin in Gucci is quarter and the first coin in Louis is dime? Return false. Right away, you're done. As soon as you hit a return, the method's done. You can have multiple returns in your method, as long as you can reach one of them somewhere, right? All right, so as soon as the two coins don't match, return false. But you got to check every pair of coins. The first pair of coins in each purse, the second pair of coins in each purse, the third pair of coins in each purse. As soon as it fails, return false, you're done. That sounds like a loop, right? But is it a for each or a standard loop? Standard for? Is it a for each or a standard for? Not a for each, because if you read the specification of for each in the Java API in oracle.com, it doesn't specify the order in which you're traversing the array list when you're doing a for each loop. I want to have more control. I want to actually have indices. I want to have an I sub equals 0, so I can do a sub 0, and I equals 1, so I can do a sub 1, and I equals 2, and I can do a sub 2. Right? So I can do like a set I, or a get I, or an add I, or a remove I. Right? I want to be more specific. So I'm going to do a standard for loop with a loop counting variable like I, j, k, something, whatever. So how do you set up the loop? Okay, for int I equals, well, what's the first index in an array? 0. Semicolon. Okay, when do you stop?
I equals size.
Well, as long if I equals size, that's too big. So how about until I is less than size? Now, whose size though?
Does it matter which size?
Well, yeah, it does. What if they're not the same size?
Take the longer.
Well, what if they're two different sizes though? What if one person has 10 coins and the other person has 3?
Well, check if they have the same length.
You have to do that first. This is a massive problem. What if they don't have the same length? And you go through say one has a length of 10 or a size of 10, right? And the other one has a size of 3. And so you go sub 0, sub 1, sub 2, sub 3, all the way up to sub 9. But you can't go up to sub 9 if the size is only 3. That's going to give you a runtime error. It's going to say array out of bounds exception. You don't want that to happen. Remember when that used to happen in C that blew up our graphics arrays? That was fun. Yeah.
Oh, that must have been a real laugh.
Yeah, that was a lot of fun. Java won't let that happen. It just gives you a big error. All right? So we have to check first if they have the same size. What if they don't have the same size? Can they be the same contents? If they have a different size, they're going to be the same contents? Really? No. All right, so the first thing I'm going to do, if they have the same size, then I'm going to do the loop. If they don't have the same size, return false right away. Oh, okay, so I'm going to put this loop inside of an if statement, because I can't do this loop unless they're the same size. It's going to crash my Java runtime. It won't crash my Java C. Java C will be perfectly happy to do it for you. Okay?
It won't actually work.
It won't work when you Java it, right? Okay, so what is my if statement? What's my if statement? Guys, pay attention. What's my if statement? Yeah, what? I got that, thanks.
Really, guys?
If what?
If Purse,
No.
if Gucci,
No. If coins, okay. If coins dot
Something.
something. Oh God, this is pathetic, guys. That size, okay. All right, what should I write here? 6? No. 6? How random is this? What? Well, all right, I'm going to do it this way. If it's equal, I'll do the loop. If it's not equal, I'll return false. So how do you know if they're equal? Equals equals, right? That's a big deal. Don't forget equals equals. Equals equals who?
Temp dot coins dot size.
Temp.coins.size. Do you see what's going on here? This is this. You could actually write this dot.
And that's silly.
Okay, but you don't have to.
It's so much easier to write the if not, because you don't have to do the
I-
else. You have to write an extra else statement.
Yeah, but I need to return false somewhere. Somewhere along the line, they got to return false when it's not equal.
Right, but you have to write an extra line.
Oh, you'll live. Okay, do it.
No,
Fine, do it the other way. I don't care. It's fine.
I know.
Okay,
I'm saying you're making
it's the same thing.
You're making more work for everybody.
I want them to understand what we're doing. Okay. All right, Sean, let's pay attention to what we're doing. Okay. So if the two coins have the same size, then let's do the for loop, because then the for loop can go size and cover both. If they both have the same size, say 10, the loop has to go that many times for both. All right, so that's good. All right, now listen. Shh. Who's this? Which one? Gucci. And who's temp? Louis. But it doesn't have to be. It could be any two persons we create in the tester, right? It just happens that in the tester I have Gucci.sameContents Louis, right? Okay, so this is the array list of Gucci. This is a size method from the array list class. This is the array list from Louis, and this is a size method from the array list class. We can do that because temp is a purse, but temp.coins is an array list, so I can use size on it, right? Is this okay? All right, so let's put the then clause, let's put the for loop in the then clause. Let me skip that for a second. What's your else clause going to be?
Return false.
Exactly. So if they're not equal sizes, then for all bets are off. Then they can't have the same contents. So return false right away. Okay? Okay, that's good. This is error trapping. Because if they're not the same size and you try to traverse the bigger one and compare it to the smaller one, you're going to crash.
But here's the thing, though. You can actually do that. You can. Isn't there a command that says if there's an error, return this instead? You don't count the error.
We can capture exceptions, yeah. We can catch exceptions, but I'm not doing that right now.
Yeah, it's mad work and kind of silly, but it is possible.
Yeah. All right, so let's finish the for loop. For int I equals 0 to I is less than what?
Coins.size. Now it doesn't matter which size.
Now it doesn't matter which one. Does it matter if I do this dot coins or temp dot coins?
And it doesn't matter, and since I'm lazy, I want to remove the word temp dot, because that's so much typing.
Okay. Well, no, temp you need.
No, I don't.
This you don't.
Yeah, that's what I mean. I can just write coins.size instead of...
Right, and that I'm going to do the same thing, yeah.
It's so much
All
less
right, okay,
typing.
coins.size. All right, you don't have to write to this. By the way, if you want to write to this to make it easy to distinguish between the two objects, make it easy for you to understand what you're doing, by all means, do so. All right, so for I equals 0 to I is less than coins.size, semicolon what?
Everything.
No, I know, what goes here? What goes here, guys?
We'll check if each one is equal.
No, not yet. I plus plus, right, okay.
Sorry.
All right.
I thought that was implied.
Unfortunately, nothing's implied around here. Okay.
What about 2 plus 2 equaling 4?
Only in base 10 or base 5.
I want to do that on all bases greater than 3, right?
Yeah. Okay.
It'd be so funny to do that on a math test.
Greater than 4.
What?
Greater than 4. Base 4, 2 plus 2 is 10.
Oh, right.
Right. Yeah, you should be. All right, so, that reminds me. Yesterday was my birthday, right?
We went over this yesterday.
No. So
Here.
you were partying for my, yeah, I know. You went off and partied without me. It's great. Okay, but wait. On my Facebook, people went nuts and posted all kinds of craziness. Look what I got from an ex-computer science student by the name of Chris Rye. Do you know who that is, really?
I said I don't.
Oh, okay. Yeah, he graduated, I think, maybe 5 or 6 years ago. Look what he wrote. Where is it? There it is. Look what the heck he wrote.
Wait, did you write your
Look.
basic code?
Where did it go? I just had it. Basically. Where did it go? There it is. See it?
I would have done it in ASCII.
Well, that's what he did.
Nice.
What the heck did he just write?
Okay, that's a string of Unicode, or assumably Unicode, because we're doubting that they're going to use American system, of characters that would give you...
If you convert these binary digits, this binary number into decimal, you get, what would he get? 1s, 2s, 4s, you got an 8, 16s, 32s, 64. What's 8 and 64?
A decently sized number.
8 plus 64 is 72. 72 happens to be the ASCII code for the letter H.
Yeah, okay. He definitely
Guess what he
put that in
wrote?
the translator.
HAPPYBIRTHDAY something. Maybe that, something in here is a space or something. So he wrote happy birthday in ASCII. Amazing.
Yeah, no, he typed that into a translator.
How do you know?
Okay. Anyhow.
I've done it before.
But I know how to do it.
Yeah, but you can do it very easily, yeah.
Yeah, because you definitely have all of the codes memorized.
Okay. All right, so now, all right, so remember what we're doing. Now that we know, if we're here, if we're running this code, we know we have the same size,
Then you are clearly
and now we're checking each coin of each array list to see if they're the same. So how do I get a coin from each array list? What's the accessor in the array list class that doesn't mutate the array list, just looks at what's there, like at sub 3 or something? There's a size method. There's a constructor, obviously, right? There's a size method. There's a remove method. There's 2 add methods. There's even the clear method.
Right, which is really cool.
But what's the one, by the way, the clear method is not part of the AP Java subset, so you won't need it on the AP exam, but that's okay.
Can you use it on the AP? Yeah, you can.
You can use it. They'll know what it is, yeah.
But they'll be kind of like,
It's like, where did that come from? Well, Java is such a has so many libraries. It's such a humongous language that they pared down certain specific things that you must know for the AP exam. And .clear is just not one of them, but whatever. Which is the accessor in the array list class that lets me see what's in the array list? Dot what?
dot life.
No.
Dot 42.
Yeah, that's it. Dot. What do we usually call any accessor, by the way?
Get.
Get something, right? So guess what? Dot. It's just dot get. Okay.
Wait, really?
Yeah, that's what it is. All right, so I have to ask, I'm asking a question now. I want to know if the dot get from one array list matches the dot get at the other array list at I. I is ranging from 0 to size minus 1, right? Whatever size is, if it's 10, we're going from 0 to 9.
So let me guess, we need to write another if.
So you have to write another if. If what? Coins.get I.
Equals
Well, wait a minute. Remember what coins.get I is. What type?
integer, right? No, string.
It's a string, like
So we
quarter.
need- So we need dot equals.
Okay, excuse me, gentlemen. Are you paying attention or are you just yapping?
Dot equals other dot.
Stop talking, guys.
coins dot
All right, this is an important point here.
I.
If you do coins.get I, what do you get? You get a coin, right? But what type is that?
That is crazy.
This is an array list filled with what type? Remember, array lists can only have objects. What object type is in this array list? A bunch of what?
String.
Strings, right? Like quarter, like dime, like nickel, right? You can't do equals equals on strings because strings are objects. Well, you can, but it's not going to do what you want.
No, in some cases, if you do two string literals in a row that are the same thing, you can use equals.
If they happen to be, yeah. But what I want to know is,
And I was like,
Okay, I want to know is if the get I from coins in this.coins and the get I of temp.coins, right, is the exact same string. Now, how do you compare strings? You don't use equals equals because strings are objects, and if two objects are equal, that just means they're stored in the same location in RAM. An object variable stores a hexadecimal address location in RAM where it's in RAM, right? I don't want equals equals here. What do I want?
Equals.
Dot equals. The dot equals method of the string class. Coins.getI is a string. So I got to use the dot equals method of the string class. That's not unusual. If you're doing an equals method in a new class, you tend to use an equals method of another class to help you. Okay? All right, dot equals what? Other? Well, did we call? Yeah, but be careful. Other is an object.
Wait, don't we need other?
I don't want other. Who do I want?
Don't we want other .coins?
I want temp. What?
Oh, I forgot.
Right?
Oh, right. I forgot.
Okay, I have temp dot what?
Temp.coins.
Coins.getI. Right. So what that does is it compares to see if these two strings are equal. The ith string in Gucci and the ith string in Louis. And if they're equal, well, wait a minute. Do I care if they're equal? I care if they're not equal. Didn't we say as soon as they're not equal, return false, you're done? All right, so how do I make this a not? Exclamation point around the whole thing, right? All righty, so
then that just returned.
yeah, all right, let me put this whole thing in another parentheses. So this is the parentheses for the if. Then the other parentheses is to figure out if this thing is true or false, what's inside there, right? And then I want to negate that, which is shift 1. All right, so if they're not equal,
Okay, that should work now. I think I got it.
if they're not equal, what are you going to do?
Explode.
That's it, explode, right. That's another method of the array list class we're not tested on, dot explode.
Wait, really?
Yeah, in other words, return false. Okay.
Wait, there's no dot explode, is there?
No. All righty. So, now, all right, so
Wait,
that
you can write string.extend string, right?
string dot, oh, you want to extend the string class?
Yeah, and can we include dot explode?
Well, what's your new class called, though? Superstring? Super?
No, just rename string. Like, save string, right?
Yeah.
And rename it. Then extend to that new class and call it string, overwriting the original string class. So we make a temp string.
Okay, great.
And then our new string class is going to contain.
All right, I don't think we need to do that right now. All right, focus, here we go. All right, so what's going on? If the two array lists are not the same size, return false right away. If any one of the get I's in Gucci doesn't match any of the get I's in Louis, return false right away. But what if it never returned false? Then it's got to be true. So here, return true. If you get through this whole mess and you never returned anything, guess what? It must have been true. They must have been the exact same contents. The only way they're not going to be the same is if they're not the same length or if any individual pair of coins don't match. If you pass all of these tests, then you better return true, right? There it is. All right, this is ready to test, okay? Now remember, we don't have a very good test here. We have a Louis, which is empty from last time, right? Because what did we do? We did transfer. We did Gucci.transfer Louis, so Louis is empty, and Gucci's got everything. So this better return false, right? Because remember the tester. It's just testing to see if Gucci has the same contents as Louis, and we know it doesn't because Louis is empty, right? All right, so this should say not, or we messed up. Let's test it. You ready to test? Here we go. All right, Java C, Purse, driver. What'd I do?
I have like misspellings.
Uh-oh. Wait, I don't have enough parentheses here. I have too many. Wait, I have the open and close for if. I have the open and close for that. Oh, I don't have the close for equals.
Wait, sir, why not just use there's a setting that will tell you
Yeah, what's that setting? I like that. I used to have that in Kate.
I have it on right now. It's under preferences somewhere, right?
Oh, yeah, all right. We'll fix that another time. Let me just make sure I got this done. All right, so, yeah, sorry, I messed up. I forgot to close the equals method.
I found it. It's preferences. And
Yeah.
at the bottom, highlight matching bracket.
Okay, I'll fix that later. Let me just make sure this is tested. Yeah, I used to have that in Cape. That was so nice. And then not in gedit. All right, sorry. Let's clear this. Let's Java C this. Let's Java it. And it should say not the same, right? And not the same. Perfect. All right, we're done for now because we're running out of time. But we have to change the tester to see if true works. We're going to have to make two new purses that are the same and see if true works, okay?
We can just add things to,
Or add things to Louis or whatever. Remove things from whatever. Make them the same and see what happens, okay? All right, but that's it for today. All right, bye-bye, YouTube.